Hello everyone. Welcome to today's session on Rise with Google Cloud. My name is Sujata and I am a customer engineer specialized on Google Workspace from the Google Cloud team. Being a fresh day, we have now come up with two fresh topics around Google Cloud. And before that, we have Rajat Pandit doing the leadership kickoff. Rajat has spent about 2 decades in IT now, with half of it leading engineering teams at some of the largest media and retail organizations of its times. He's leveraged his learnings from the first half into the second half to help large enterprises in consulting roles at one of the big 4 firms, including at one point running a small consulting firm himself in the UK, helping startups and enterprises adopt cloud. Rajat is currently leading a team of highly talented cloud architects. I sometimes wonder how much magic this team does. And they work with customers to build and develop solutions that become key drivers for their business growth. So over to you, Rajat, to get started.
Perfect. Thank you, Sujata, for that introduction. And welcome all to the concluding session of Rise with Google Cloud. Hope everyone's doing well and enjoy the session so far. I'm incredibly excited about the next 2 talented speakers, both Seema and Srini, especially since they will be covering 2 of the hottest topics in IT today. Both AI and analytics capabilities are at the core of business today. When it comes to making intelligent business decisions and building smart products and proactively preparing for the future. So just to provide some more context, just in the last 15 years, there's been some massive advances in these fields. So what has really changed? Obviously, we've got much faster computers that can do much faster calculations. And clearly, we're spoiled for choice when it comes to choosing compute architectures, given the easy access thanks to major cloud providers. We also have had some breakthroughs in theory and maths that have helped optimizations of problems much better. So really the efficiency of the associated algorithms have gotten a lot better too. But more importantly, our ability to store, consume, and make sense of a lot of data has improved significantly. And with all this data, we have now more data points to train our machine learning models on, right? So with all of these 3 things combined gives us really these current advances in deep learning. But if you just take a step back and looking at what it means as an opportunity for IT professionals early in their career, the opportunities are just enormous, right? Between the triangle of like researchers, data scientists, and developers, there's a lot that can be done in this space. And if you're a math geek and love algorithms, you can invest in research to identify, develop, and build new algorithms. You can have them to solve new problems or improve upon existing ones. And that's really the whole opportunity scene that you've got there. As a data scientist, you can develop skills to clean, transform, and make sense of large volumes of data at scale. And you can develop deep understandings of algorithms so that you can make the right choice of the algorithm for the right problem and customize its parameters and build models around it. And the third part is as a developer, right? You can learn to develop interfaces to engage with these models and provide inputs to their application flows. And with all these AI-led applications, it is quite obvious that this will naturally become the norm, that you don't have to write applications that have a complex web of if then else conditions, but instead, you just call these models and they will suggest the next course of action based on hundreds or even thousands of these input parameters to understand context and make a decision, right? And this mode of development will also get your application to evolve as it interacts and learns from past interactions as well. So the future is just phenomenally exciting. So moving on, just a bit of more context around applications and data. Our applications today are emitting more data than ever before, and our ability to convert this dark data into meaningful insights is really the field of analytics is all about, right? And this is a very interesting and challenging field in computer science, as the complexity and cost in these 2 areas that scale out very quickly as the volume of data increases. And the role of a data engineer or a data analytics specialist is to solve this exact same problem. So today, Srini would be covering how the same technology that helped Google in its initial days when it began to crawl the entire planet's knowledge and data is now going to be available at the end of users like yourselves with tools like BigQuery, etc. And he will also cover how you're no longer being constrained by the cost and complexity, and help companies in their mission to be data-driven organizations, just like Google is. So with that brief introduction, I'm very excited for the rest of the day, and I'd like to hand it over to Sujata to take it from here. And wish you all a very good day, and hope you enjoy the rest of the presentations. Thank you.
Thank you so much, Rajat, for that introduction. Up next, we have our next speaker for today, that is Seema. Seema is a specialist customer engineering leader at Google Cloud. She's leading a team of experts in data analytics, AI, data management, and app modernization. With over 16 plus years of experience into data analytics, she's worked on a variety of roles in data engineering, data sciences, and solution architecture. With her experience in several countries like US, South Africa, Australia, India, she's worked with clients in banking, mining, manufacturing, retail, and healthcare verticals. She excels in combining business acumen with deep technology expertise in data and analytics. Seema holds an MBA from SP Jain, a BE in information science, a senior data architect certified from Accenture, and a certification in machine learning from the University of Washington. She enjoys biking, runs a children's library, and has played chess at nationals, and lives in Bangalore with her entrepreneur husband, along with her two lovely daughters who share quite a lot of interest in quizzing. Now, the topic here is all about AI and ML. AI at Google gives us a glimpse of how the AI-powered planet-scale apps are run and what powers them in the backend. We would also be looking at how companies are adopting AI in different verticals, different industries, and how the pandemic has helped with a renewed adoption of these services. We would also be understanding details around ML operations with Google's Vertex AI. With that said, I'll now quickly hand it over to Seema for the talk.
Thanks for that really good intro, Sujata. And in addition to everything you mentioned, there are really two things I'm passionate about. One, developing women technology leaders, and second, data analytics and AI. So this is a forum that brings the two together. So I'm really excited to be talking to this cohort of women in technology on ML. So let's get started. Let's go cook up our ML recipes with Google. So here's what we will cover today. What does AI look like from inside of Google? Adoption of AI across different industries, and some of the challenges that prevents ML from being industrialized in several industries. And then there is ML ops with Google. So that's really how you address the challenge that I talked about with regards to ML ops. So first things first, Google is an AI company. We have a mind-boggling number of projects that we do around AI. And as you see in the graph on the left-hand side, we're now at about 7,500 projects in 2017 Q3. And that number keeps growing at a staggering pace. And all of that shows in the kind of applications that we run, be it Gmail or Maps or YouTube or whatever else that Google produces. There are over 9 of those applications that really have 1 billion plus users. So these are powered by AI at Google, and this really is the living proof of AI at scale and how Google has really cracked that difficult puzzle. Here are a couple of examples that bring this to life. So this is a picture of how an exit board is being scanned by a phone, and it's leveraging Vision API internally to do this. And then there is a Translate API, which helps to translate this to a local language and displays what it means to a user who's not proficient in English. So really cool stuff and good implementations of AI right there. Another example is photos. So let's say you've taken an awesome vacation, you've gone to a beach or you've gone to a place where there were glaciers, and that photo is stored away amongst the millions of photos you must have clicked after that. So when I go to my photos on an Android phone, I can just search for a beach, a glacier, a dogs, and it's able to pop up the right kind of images that have whatever it is that I'm looking for. So that's another great example of image classification and how Google gets this absolutely right at scale. Another example, smart replies. So there are nudges in Gmail which help you type your responses without having to type those responses. So there are auto suggestions that are enabled. And today, over 12% of all the responses that are sent on your mobile come from these auto suggestions that are provided by Google. So those were a glimpse into some of the consumer apps that really use AI at scale. But let's take a look at how AI is applied under the hood as well. So if you look at some of the data centers, right, these gigantic things that Google really runs at scale for powering all of those applications that I talked about, we've been able to save our data center cooling energy by over 40%. And that has improved power usage effectiveness for 15%. So if you look at this graph, you see that there's a clear dip when your ML controls are on, and then that dip really resets itself when you turn off your ML controls. So clearly proving that ML's behind that energy saving and the energy efficiency that you saw on the graph. With that, let's quickly look at how AI is really being adopted across industries. 2020 was truly a tipping point, in my view, in the adoption of ML across the industry. And why do I say this? The pandemic obviously came in that year, and then it raised a lot of question marks as to what would happen to AI adoption across industries. At that point, about 40% of companies had adopted AI in some shape or form. And when the pandemic struck, what was really interesting was 47% of those companies continued to stay invested in AI. And then there were another 30% that said they were in fact going to increase their investments in AI. And there were a number of use cases across industries which had already proven the use of AI for solving real world business problems, be it demand forecasting in retail or telemedicine in the case of healthcare, even robotic care delivery. Then there were financial services, which has really established some of these use cases at scale, like your fraud detection or KYC, eKYC. And then there's lending doc processing and so on. So across these different sectors that you see here, there were a number of use cases that were already well established, but there were two things that COVID did to this landscape. One, it truly stress tested some of this, because look at retail, for example, right? There were customers that were pouring into your offline stores, and you had models that would work to analyze those customer preferences, suggest some things that the customer might like, maybe help with planogramming and stuff like that. But as soon as the pandemic struck, there were a lot of those customers who just shifted lock, stock, and barrel to online channels. Now, that's a fundamental business shift. How do you really change your ML models really quickly to be able to address that, right? So that's the kind of stress test that COVID put on a lot of business models, and therefore the associated ML models at the back end. And it also did something to fundamentally catalyze the rate of adoption of AI across these industries. Let me give you a good example of that. So for the retail example that I was just talking about, we worked with a retailer in EMEA, and because of that shift from offline to online, they had to churn out ML models much quicker, and they were able to do this in less than 2 days. Imagine taking a model to production scale in less than 2 days. It's unimaginable for most companies in today's world, where they struggle with all of these challenges that I'm now coming to, which really prevent adoption of ML at scale. So there are cultural challenges, there are challenges related to data. You just don't have good quality data. The skills are very, very sparse in this area. You really need people who are great at statistics, understand the business domain really well, great at technology to be able to crack it as a really good data scientist. And that's asking for a superhuman, as you can imagine. So that's a fundamental impediment to adoption of ML at scale. There are also technology challenges, because these models are so data hungry, so compute hungry. These, especially if you're building things like deep neural networks, for example, right? The consumption is tremendous. So how can you scale this kind of technology? Unless you're in the cloud, it's very, very difficult to really do this. Then there are ops challenges, which I'll deep dive into in just a bit. But the big picture is that so far I talked about the rosy side of AI adoption across industries. And there is, however, a huge flip side to AI adoption because of all these challenges that I talked about. What it essentially translates to is that less than 13% of your data science projects actually make it to production scale, which means they're in the garage, you're experimenting, they're yielding great results, but is that enough to really translate to business value? And that's further corroborated by the fact that there's less than a quarter of these companies that actually report a 5% plus EBIT impact because of their AI initiatives. So deep diving into that ops challenge, as I promised, which is the crux of what we want to talk about today, that really happens because a lot of companies view ML projects as, let me code, let me get a good accuracy on my model, and then I'm all sorted, right? But there is a plethora of things that really go into making your ML projects really successful. Have you thought about the challenges that might come in with doing data collection, data preparation at scale, so that that data is truly ready for models being built on top of it? Have you done enough exploration and analysis on that data? And when it comes to actually building the model, there's one thing about doing all of this in your dev test sort of environment, and then when you put it into production, your production data is almost always quite different from the data that you use for dev test, right? Because in your dev test, it's gone through your ETL process, the significant transformation that's happened. So inevitably, your training data looks quite different from what your production data could eventually look like. Have you considered those things? And then when you finally overcome these and you're able to put a model into production, are we monitoring those models for drift? Because often we crack the champagne and say, oh, wow, here's a product we've been working on for like 3 months now, and finally we've got it into production. But then you revisit it 3 months later, and then you see how the accuracy has dipped. You need an automated way to be able to monitor this and fix it through retraining whenever that drift happens. So how really can we look at MLOps a bit differently? Now, fundamentally, MLOps is an amalgamation of 3 things, right? There's data engineering, there's software engineering, and there's data science. So we can pick best practices from all of these to ensure that our MLOps is really effective, which means some of your decade-old experience that we've got in the software engineering space, because concepts like CICD, for example, are really well established in this space. So we look to learn from there. Similarly, with model development, there is this whole process of developing an MVP, then eventually getting into deployment, which is slowly becoming a well-oiled machinery. So we can learn from there. And the whole bit around data pipelining, how do you really source data, make sure that it's prepared well, analyzed enough to be able to make it suitable for modeling. So we bring together all of these to offer something called MLOps. And what are the key phases, therefore, in ML process when you try to develop an ML project? So there's this bit around developing the ML model, as training, operationalizing that training. And then we need to think about how we continuously train the model. So there is a feedback loop that needs to get built, and then finally can deploy it. And then when you serve predictions, there is a bit around how you monitor it continuously. So it's really about bringing these together in a process which brings together the best practices from software engineering, DevOps, etc., to make this workable at scale. That's really what MLOps is. So if you look at the maturity of companies on MLOps, the first phase is where they're just very, very manual in everything that they do, and this is what it really looks like. So your whole process of extracting, preparing, training the model is all manual. And then once the model gets trained, there is a bit about handing this off to some kind of an IT ops department, which really looks at scaling this model, deploying it, and monitoring it thereafter. The next level of maturity is really where we look to automate some bit of that pipeline. So as you can see here, this automated pipeline really takes care of your extraction, validation, preparation of that data, training the model, and so on. What's also really interesting about this is that you try to bring in some pieces around a feature store, which makes it easier for you to share model features, therefore bringing in an element of shareability, reusability to your models. And then in the most mature stage, this is where you're also looking to incorporate CICD. As you can see here in numbers 2 and 3, you incorporate a CICD pipeline as well into all of what you did in maturity level 1. So automating a lot of this saves time, energy, costs, and it really is key to make sure that you can get your models out to production very quickly. So how does Google really help you if you want to develop ML projects? There are 3 options that you could consider. So if you're already a BigQuery user and you've got users who are really comfortable with SQL, then the obvious choice is to just go use BigQML, because BigQML comes inbuilt with a number of commonly used ML models that you can just use straight off the bat. So we've got regression, classification, linear regression, even booster trees, algorithms, and so on, which are built into ML. So this is really about SQL users being able to do ML without having to do a whole lot of upskilling in the process. And there is another option for users who are not really into the thick of coding, right? There is a number of packaged APIs like your Vision APIs or NLP APIs, which you can just call as an API call and then use it in your applications. So that is where Auto ML really comes into picture, because it offers these out-of-the-box APIs that can just be called from your existing applications. Finally, there is Vertex AI. This was a fairly recent launch a few months ago in our AI/ML Summit, which happened around May. And this is a fabulous platform because it really brings together everything that I talked about, right from how do I extract data, process that data, build my model, deploy it, monitor it, implement the CI/CD pipeline. So it brings together all of that in a single pane of glass. So what really do you get with Vertex AI? Your velocity of models in production improves tremendously, which means you have fewer iterations to do, quicker iterations that are possible, and you can put more models in production quickly. So you're not really talking about 3 to 4 month projects before you crack the champagne anymore. These are really cut down to a couple of days when you can put your models in production. And what you also get is Google's best-in-class algorithms as a service. Like I set the stage at the very beginning, there's a plethora of things that Google really does very well around AI, and we're the best in the industry and recognized as such by most analysts. So you really get all of that that Google does. We are now offering it to our customers through whatever we bring to you in Vertex AI. It also offers you an option to scale your ML workflows quickly and then do your model management and governance, which is typically a manual process in most companies. In terms of what it takes to really use this product, it has been built for a plethora of users. So you might have, on the one side, there's the product manager, the business user, who really asks queries and would like to get answers and not really delve into the details of preparing data or engineering or trying to code things to make a model work. So for those types of users, there are already dashboards that they can use. And then there are also a plethora of data engineering and ML roles, as you can see on the slide, that the platform really caters to. So here's a bit of an under the hood look at what Vertex AI entails. And for traditional users of Google AI, you might be familiar with the AI platform that we offered previously. It had a lot of these capabilities, but in siloed manner, which means that you would have to stitch together some of these capabilities to really make it work end to end. Vertex AI requires no stitching. So you really get off of this product, and then everything that you need from your pipelines all the way to using some of the most sophisticated AI algorithms that we have to offer are all available within Vertex. So there are a number of new features here, as you can see, and just in the interest of time, I'll pick a couple of things that are really interesting and talk through those. So you've got ML pipelines, which really make it possible for you to have fully managed pipelines. They're based on SDKs, they're scalable, super cost effective. And the interesting feature about this is that it lets you track your model metadata. So when you run your model, there are a number of things that you need to really take cognizance of that are associated with the model, right? It could be the training data set that you used, it could be the code that you developed, it could be the accuracy of the model output, it could be things like how many iterations did you run before you actually got to the acceptable level of accuracy, and so on. So that kind of metadata tracking and lineage is really enabled in Vertex AI. If I could just go back here for a minute, there are a couple of new features in here that I'll talk to you about. So this feature store, which makes it super convenient for users to be able to share things that they once developed. So let's say I'm trying to create a model for an e-commerce customer, and that would entail gathering customer demographic info, their preferences and such. Now, it's certainly not one model that we develop for a whole e-commerce firm, right? You might want to reuse that data for a number of other related models that you develop. So rather than having to start from scratch, you can put all of this into a feature store, which then makes it shareable, and then your models can scale with very low latency because you really don't have to start from scratch to build all of this again. It also helps you avoid your training serving skew because once you train your models in dev test, like I mentioned, the production data might look quite different. And if that drift happens, you can catch that early on. Then there is this feature around matching engine. So this is a really interesting graph that I want to showcase here. This just shows how matching engine is 30 to 50% cheaper than a lot of other alternatives that you might use for matching models. So if you compare it with the likes of your NGTs, or you've got your SW graphs, which is NMS-lib, you see that the purple line there really converges. It's a much steeper line than the rest. That shows that the rate at which these models converge is really way faster than any other comparable models that you can see in the market. So it's literally 1/4 of your CPU consumption to do that, and 1/3 of the memory consumption, which makes it a really fast, really cheap, really low latency option. So this is one that I'm a big fan of. And then going back here, you see that you've got your Vizier and NAS. So those are two final features that I'll talk about. Vizier is incredibly useful for people who are data scientists and who are struggling to get their hyperparameter tuning right. So when I used to build my ML models as a data scientist, building your models would look something like, okay, let me adjust a few hyperparameters. How many layers do I want to stop at? Maybe what is the accuracy threshold that I would want this model to go after? It's really manual to have to set these hyperparameters, run your model every time and see how it performs with that set of hyperparameters. If it's not great, you'd want to go all over, back again, tune the hyperparameters and do this all over again. And every model run might actually take days and weeks to complete, depending on how complex it is, right? So this could be a really draining process for a data scientist. And what Vizier does is, cool, it automates that whole thing for you. So it experiments with a number of hyperparameters. And then it also has this really cool inbuilt feature where, as it experiments with different hyperparameters, when a model runs, it's able to predict whether that model might lead to a fruitful outcome or not. And if it's not likely to lead to a fruitful outcome, it can just stop that right there, rather than having to complete a run like you would in your manual process and then looking at the parameters. So this is really cool in the sense that it builds in those predictive features and lets you tune your hyperparameters automatically and therefore do your model selection more easily. And finally, there's the neural architectural search, where it's able to provide an architecture based on what kind of model you're trying to build. We really use this in high-end applications like Waymo within Google. So that's a quick overview of all the cool things that Vertex AI has to offer to really ease MLOps and help you move up that maturity curve that I talked about. Hope that was interesting. Thank you.
Wow, Seema. Thank you so much for those insights on AI and ML. I've always been amazed with the Google's self-driving car, which started off in 2009, Waymo, and how AI and ML has been leveraged in the back end in order to help those cars running on the ground. So thank you so much for additional insights, and this just helps me enlighten it or strengthen my belief on AI a lot more. Now that said, we'll move on to the next speaker today, and this is where I want to introduce to you all Srinivas Makam. Srini in his current role is an app mod specialist, designing and architecting solutions for Google Cloud customers. Prior to Google, Srini has worked in Cisco systems and a bunch of startups. Srinivas has a strong background in containers, networking, and modern applications. He's also an active speaker at conferences and meetup groups. Srinivas has been a Docker captain for 2.5 years, and he's an active blogger in the cloud and containers domain. I've also seen several of his video blogs on YouTube. He's also written a book on core operating system and containers, which you should definitely look up for. Now, in the upcoming discussion, Srini will take us through the power of data analytics in Google Cloud, how to draw those real-time insights and data apps to derive or drive decisions and innovation. That said, there are several times that I've seen users spending hours together waiting for Excel sheets to open, which are extremely large, several MBs or few GBs in size. And once the sheet opens, it again takes a lot of time to process or draw insights from the data that has been loaded on the sheet. Now, that said, this task has been simplified just using a BigQuery data table. By leveraging connected sheets on Google Sheets, you could easily connect to a BigQuery data set and slice the data, dice the data, and derive all necessary analytics on top of it. So this is one example that I've used, but in the upcoming session, I'll hand it over to Srini to discuss on how to use GCP Analytics to find a needle in a haystack. Over to you, Srini.
Thanks, Sujata, for the introduction. Hello, everyone. Welcome to the Rise with Google Cloud series. We all know that data is wealth, and we also know that there is a lot of data, right? I think the important thing is kind of getting value out of the data, which is almost like trying to find a needle in a haystack. So in today's session, I'm going to talk about how we can use GCP Analytics to find a needle in the haystack. My name is Srinivas Makam. I'm a customer engineer focusing on application modernization within the Google Cloud team. So we all know that Google is a data company, and you look at any of the product that Google has, right? Whether it is search or ads or YouTube, cloud, maps, photos, we have a lot of data that you want to process. And if you look at what is the mission statement of Google, it is about organizing the world's information, making it universally accessible and useful, right? And what does the information mean here, right? The information actually is the data, right? And how do we get value out of the data? Either it could be processing what data that is there earlier present, or use that data to kind of predict the future, right? And once we make that data useful, we want to make that accessible to everyone, right? And that has been the Google's mission for the last 25 plus years, which we continue to adopt in newer technologies. And this is a very interesting thing, right? Data is a very strange currency. It is ubiquitous, but it is very valuable. And we also know that data creates competitive advantage, and that's something pretty well acknowledged everywhere, right? But the bigger problem is in terms of how do we separate the chaff from the wheat, right? And this is the bigger problem. And if you look at every industry, 80% of everything that is written is shaft, which is kind of the boilerplate stuff, and the value comes from the 20%. And that is how every industry, whether you look at retail industry or a fintech industry or a manufacturing industry, that is how they kind of differentiate themselves, right? And what are some of the important problems that we want to solve here, right? First thing is, how is the data going to add value to you, right, as a customer? Again, first thing is identifying which industry space we are in, what is the data that we have, and how does the data add value. The second problem is in terms of how does organizations help with democratizing data. And this is a term a lot of you folks would have seen it. What does democratizing easily means, right? It really means that your data is accessible to everyone, not just to data scientists or people who really know how to process the data. Any business user should be able to take the data and get some value out of it, right? That's pretty much what it's called as democratizing data. The second is in terms of how quickly can your system evolve, right? For example, let's say if you have a new data source that has come in, how can you adapt your system so that you can take that input from the data and take value out of it, right? And the last part is in terms of you want a platform that is scalable, and you only pay for what you use, right? So those are some of the important characteristics when you look about in terms of separating the chaff from the wheat and trying to get the value out of your data, right? And if you look at a typical data analytics problem, so the way we typically look at it from within Google Cloud is, you have a bunch of data that is coming in, which we call it as a data stream, and then there is a black box that is sitting in the middle, which does a bunch of things, and then you get some output out of this data, which is the ones that is going to be adding value to it. And these could be things like a report or a dashboard, or it could be some kind of a prediction that you can do, which is adding value to your business, right? And I'll give you examples as we kind of walk through this, right? And what we do in this black box, right? The black box, what we do is, we ingest the data, we process the data, we do a bunch of, machine learning stuff, and then we allow you to get insights out of this data, right? And that's, kind of what, we do here. Just to give an example, right? Think of like when we think of something like a reports, right? What we try to do here is, how does the customer's business pattern kind of changed over the last 5 years? What are my top selling products? When you think of examples like predictions, think of like you're going to a website and the website tells you based on your past history what kind of recommendations it can give, right? Let's say, for example, you go and do a transaction in your credit card, and you kind of sometimes get an alert telling that this looks like a fraudulent transaction, right? So these are examples of where we are able to use the data and give some value out of this data, right? So what typically is data analytics, right? And I kind of hinted along this as we looked at earlier things. It's about basically you have a bunch of input data, and the input data thing could be, let's say, what your organization is generating, right? For example, think of it like a ERP system, a CRM system, or a HR system. So these are all systems that is present within your company, and it is generating a bunch of data. And then you have a bunch of external data, right? So think of this external data as, let's say, your competitor-based data, or things like an industry trends, or anything that kind of impacts or affects your business, right? That would be your external data. And then like this, so here we have expanded this black box that we talked about in this earlier slide into slightly more level of detail, right? We talk about this, we'll kind of cover this a little bit more. At the end of it, we kind of get three things, right? One is, what is your business insights? And business insights are typically, as I told earlier, like reports and dashboards. And that's typically how data analytics itself initially evolved. The second is in terms of how is your customer interacting with your products, right? What are the things they like, they don't like? Do they respond to your notifications? And that's like the customer analytics. The third is in terms of operational efficiency. Just to give an example of an operational efficiency, you would have recently seen a lot of these grocery vendors being able to give the products to you within 30 minutes, right? And that's like a huge operational efficiency because there is a big inventory system that they have to manage. As soon as you place an order, they try to find the closest shop that has an inventory, and then they have to route the order to the right place so that you get your order within the 30 minutes, right? So there's so many things that goes in the background, a lot of route optimization techniques that happens, which allows you to get the product in the smallest amount of time, right? So there's a lot of things in the operational efficiency that goes both from optimizing your inventory to getting your orders in the fastest period of time, right? So those are a few examples, right? Now, I just wanted to quickly talk about a few industry perspectives in terms of where analytics is adding value, right? So if you look at it from a banking sector, there's banking is a huge sector, right? And if you look at it in the current trends, there's a lot of new age fintechs that are adding value in the banking, right? One example, as I told earlier, is in the fraud management. The second big sector we also see is in the risk analysis sector, right? When you give a loan to a customer, what is the probability that the customer is going to kind of repay the loans, right? This another example is in terms of segmenting the customers, right, into different tracks, right? Now, if you look at manufacturing, I kind of initially talked about how do you optimize your inventory, right? Another example that I can give is typically when the manufacturing, they give warranty for their products. How do they determine the right period of warranty, right? It could be based on looking at the characteristics of different components in your product and knowing that when a particular product can go bad, right? So those are certain things that you can analyze, based on what components that you're using in your product. So in the retail space, if you look at it, there's a lot of innovations in the retail space, right? It is about customizing based on the individual's taste, a lot of personalization, recommendations, loyalty, and the inventory management is still a core aspect of retail, right? So data analytics, plays a huge role, in many of these different aspects. So what I wanted to just cover next is a few of the customer examples in terms of how they're able to add or get value from the data, right? First, I want to talk about Ather. As you know, Ather is a great innovator in the two-wheeler electric vehicle segment. And they were trying to deal with two problems. One is, how do I extend the life of my battery so that I can go more distance from a single electric charge, right? And the second problem they were trying to deal with is how do I use all my sensors in the vehicle to optimize my fuel usage, right? So what Google Cloud was able to help Ather with is to design a pretty innovative data analytics system which will monitor the data from the different sensors that is present in the vehicle and being able to optimize the battery life, based on the different sensors. And some of these processing happens in the vehicle, and some of this processing happens in the backend to create this most efficient system. The second example I wanted to give is Purple. Purple is India's #1 beauty destination in the retail space. The problem that Purple was wanting to solve is how can they personalize the products, kind of based on the customer, right? And there were two innovations we did with Purple. First is in terms of using an augmented reality experience where the products are, more, customized for the end customer, right? And the second is in terms of based on the customer's interest, what are the other set of personalized messages that the customer can, we can show to the customer so that they have more interest in the particular product, right? So these are a few examples I wanted to illustrate in terms of both from a manufacturing and the retail industry, how we are able to use analytics to help the customers. Okay, so we talked about how analytics is helping customers, right? So if you look at what typically we do from an analytics perspective, if you look at what is on the left-hand side here, these are all the different components that you have to do from an analytics perspective, right? First, you have to provision the resource. You have to be able to handle the scale of data. You have to account for reliability. You have to account for tuning. You have to account for monitoring. So there are different aspects, right? Typically, what we see in most of the companies, they spend 80 to 90% on all these components, and only 10 to 20% they actually get value out of the data, right? And with Google Cloud, what we are trying to achieve is that we want to kind of reverse this whole process, right? We want the customers to spend 10 to 20% and then be able to get the 80 to 90% on the analysis and insights, right? So that's our goal, right? And how are we trying to do this, right? So there are five principles, if you look at it from Google Analytics perspective, right? First is we want to be able to analyze everything at scale. And this comes from, generally the Google's DNA in terms of, everything that we do is at scale. And that's the same philosophy we are trying to adopt from analytics perspective as well. Second is in terms of try to have embedded machine learning and AI in everything we do, right? The third is, analyzing data in real time. An example I gave, right? Trying to find fraud in a credit card transaction. See, this will not add value if I'm able to do this after 2 to 3 hours, right? If I'm able to do this in real time, that's when that data adds value, right? So analyzing data in real time is very important. The fourth one is, analyzing the data anywhere. So this is a critical aspect. It is not possible for all the data to move to Google Cloud. Customers are going to have a mix of on-prem and different environments. So we try to position our analytics stack so that it can run anywhere, right? And the last is, I talked about democratizing data. It is, we would want everyone to be able to get value out of the data. Now, if you look at the journey, right, in terms of how we take the data to the insights, typically there are 6 phases. The first, it starts from data ingestion. Again, the ingestion could come from a data source that is already existing. It could be a data ingestion from, let's say, a mobile device. It could be an IoT device, different kinds of data ingestion, right? Once I ingest the data, I need to kind of prepare and process the data. So what does it mean by prepare and process? It's about converting the data. It's about aggregating the data. For example, you get different samples of data, and I want to aggregate for a period of 1 hour, 1 day, right? So that's typically kind of what happens in preparation and processing. The third is in terms of, so I need to store the data. Once I got all this data, I need to have some database to store so that I'm able to query the data in different forms, right? The fourth is in terms of exploration and collaboration. So this is where the data scientists typically work with to look at this data, combine with different data sources, and see that can I add value to it, right? The analytics part is about data warehouses, data lakes. Those are all the analytics part. And the last piece is, okay, once I've got the data, processed the data, how am I going to do machine learning to get value out of the data, right? So that's typically how it is. Now, if I kind of map what Google offers in all this space, there is a whole bunch of products. Obviously, I'm not going to go to every individual product here, but the main thing that you kind of wanted to take away, I feel, is we cover pretty much every stage in the data pipeline, and we have a mix of products that are serverless, and it's very easy to use. And if you don't like something within Google Cloud, obviously you can substitute with something else that you're more familiar with, right? So that flexibility also you would have. So next thing I wanted to quickly touch upon is how has this data analytics space evolved, right? The way, typically if you look at 20 years back, again, people have been working with data from a long time. A typical example is, using spreadsheets, right? Spreadsheets has been the most easiest way of people to work with data, right? If you look at 20 years back, people typically had data marts, and that data marts evolved into something like a data warehouse. But one of the problems with this approach, which was there earlier, is data was isolated in different places, and there was no way to aggregate all this data, right? To get some an overall view of the data. And then this kind of evolved into data lakes over the last, I would say, 10, 15 years, where you are able to merge this data from different sources. The next thing that has happened is in terms of combining your batch and stream, right? So you don't just take data once in a day and import it into a database. Rather, you're able to take real-time data. And then a lot of other things about, a lot of innovations Google did in technologies like MapReduce, which kind of, gave the Hadoop ecosystem, a lot of innovations around the distributed data processing. And now we are at an era where, data is, very much democratized. You have, cloud data platforms, which are very, very highly scalable. And, it is evolving more into a space of, predictive analytics where, we are able to get a lot more value out of this data, right? So that's typically how things are evolving. So I just want to talk about one innovation in the data analytics space, right, which is the BigQuery, which is a Google's infinitely scalable data warehouse technology. And a lot of customers like it for its simplicity, where you just put the data and you are able to get value immediately, and without knowing anything about whether it is serverless. Don't need to provision your servers. It has a built-in machine learning, and the greatest part about is it has the standard SQL interface to access the data. And I will do a small demo in the end to show you how to interact with BigQuery, and you would love that interface of how to interact with BigQuery. And as I said, right, BigQuery also has integrated machine learning, and which makes it, you don't need to go outside BigQuery to do machine learning, right? And within like a single query, an example is shown in this particular animation, right? You can create a model, and you can even predict a model right from inside the BigQuery itself. So the last thing I wanted to cover before I go to a quick demo is that I want to kind of cover some of the recent innovations that has happened in the last 3 to 6 months within data analytics within Google Cloud space, right? Just to give an idea to you in terms of how things are evolving, right? The first innovation I want to talk about is something called as a data stream. And this is targeted towards customers who have a lot of traditional data sources. Think of things like SAP, SQL, Oracle. And what we found is, customers cannot just move away from these traditional data sources, right? But they still want to take advantage of the analytics stack, right? How do we do this? So the way the data stream works is we're able to take data from all these traditional data sources and stream them to Google Cloud in real time, and then we can do analytics out of this data. So which means that it doesn't impact your current transactional methodology, but we are able to use those transactional databases to get analytics value out of it. The second thing I wanted to talk about is something called as Analytics Hub. Within Google Cloud, what we have is something called as open data sets. For example, we have data sets around, let's say, weather, stocks, politics. These are all data sets people can use to understand and get value out of this data. So what we thought is, okay, we have these data sets people use, but there are data sets every company would have, right? And those would be more like proprietary data set which cannot be shared outside. So what if within the company they want to share data sets among different people, right? And that's when Analytics Hub would help. They can not just share data sets across different employees or different departments. They can also share, let's say, I have a machine learning algorithm that I found works very well for my data set. Can another team leverage this, right? So what Analytics Hub, at the end, the goal is democratize data, right? So how different people can get value out of this data. So that's the goal of Analytics Hub. And the last one I wanted to quickly touch upon is Dataplex. And the problem Dataplex tries to solve, it tries to create something called as an intelligent data fabric. The reason is what we find in different companies is data is isolated. You might have a data warehouse, a data lake, or data mart, and it is difficult to have a holistic view of the data to combine and get value out of it. What Dataplex tries to do is to collect metadata from all these different data sources and stitch them together to give an unified view of all the data available within your company, right? So that gives you so that you don't have to work in isolation, but you can have an holistic view when you try to make decisions, right? Again, these are just few examples I wanted to highlight. Okay, I think we might be running out of time, so I will quickly jump into a quick demo. So what I wanted to do is a couple of things. Mainly, I wanted to talk about BigQuery. So that's the one that I mentioned earlier. I'll show how BigQuery does processing at scale. So here, what I have is a data set from a retail vendor. And by the way, so this is my BigQuery interface, and in the left-hand side, what I see are the different data sources. By the way, this is an internal Google data set. So if you look here, so this retail petabyte here is the data set, and here within that I have a bunch of tables. Think of this as customers data, a products data, and then the sales data. Those are the three tables, think of it. So what I wanted to show you is how easy to combine and use this data, right? So if I look at my customers data and if I look at my details, there is 8.8 terabyte and there is 4 million rows in here. If I look at my products data, look at my details, there is 530 megabytes, 2 million rows. The one that is interesting I want to show is the sales data. The sales data has 1.09 petabyte and it has 1 trillion rows. So I just wanted to you to visualize the scale here, right? So we have this 1 trillion rows in this particular table, and we are able to combine all these data and we can run a query out of it. So let me run a simple query here. So the query that I'm trying to do here is analyze the sale of a data for a particular customer for a particular period, right? So when I run this when I run this query, you will also actually be able to see how much the query will process. And okay, so I've already got the results for this query. So it basically, if you look at it, it took around 3 seconds, and I am processing 1 petabyte of data, right? So I just wanted you to get a view of the scale and the speed at which we are able to process, right? So that's one thing I wanted to highlight. The last thing I wanted to quickly tell you is I talked about public data set. So what does public data set mean, and how can you take value out of it, right? So if you look here if you go to Google Cloud BigQuery, you will see a lot of public data sets related to sports, say Bitcoins, census data. Some of them are more US focused, but now we are also getting more of APAC wide data sets, like a lot of data sets on COVID-19. And these data sets are public, and you can directly go and I have seen a lot of customers using these public data sets to create really very fancy applications to get value out of it, right? And so you can pick any of this public data set and look at the data. You can create a query out of it. You can create a ML logic. You can create an algorithm. So it's very nice from that perspective for somebody who is getting started. Work on this, public data sets, get value, and then later they can combine that with their own data. And I also talked about analytics hub earlier, right? So you can then show that and share that within your organization or enterprise as well, right? So the flexibility in which how you can get started in this journey is much faster, and it's much easier as well. So I'm going to end here because we just ran out of time, as I see. And I hope you found this session useful. Thanks a lot again for joining this session. Thank you.
Awesome session, Srini, once again. I've always amazed with how GCP runs analytics, and amazing insights. Thank you so much for that. So thank you all for your time today. I hope you've gathered some valuable insights on AI and ML within Google Cloud, and also analytics within Google Cloud Platform. Hoping you continue to keep up this learning curve, and thank you once again for your time. Signing off, Sujata Dusi. Bye-bye.